welcome to another GCSE Computer Science video with me, Mr Goff, from MrGoff.com. This video will focus on binary. To help us understand binary, it's best to take a look at what we know and understand about our current counting system, denary, also known as decimal. This is a base 10 system. It's called base 10 because there are 10 possible digits that you could put in any given column, the numbers from 0 to 9. If we want to express a number greater than 9, we need a new column to record how many tens we have. This gives us the opportunity to record up to 9 tens and 9 ones. However, if we wanted to record how many hundreds we have, we need another column again. Now let's take a look at binary. Binary is a base 2 system because there are only 2 possible digits, 0 or 1, that you can put in any given column. So we can either have no ones or we can have 1 1. If we wanted to store 2 in binary, we'd need a second column that can record the number of 2's we have in our number. This allows us to make a largest number of 1 1, which would be 1 in the 2's, 1 in the 1's, a value of 3. If we wanted to make a 4, we would need another column. This pattern continues. Therefore, you can see that the column headings in binary start at 1 on the right and they double as we move across as we go left. This pattern also means I know if I have a 1, meaning I've got one of each of the column headings to the right of 128, I know that I've got 1 less than 128, or 0, 1, 1, 1, 1, 1, 1, 1 in binary represents 127. Leading zeros are any that come before the first 1 in a binary number, and they may sometimes be omitted when the number is written down. So it's important to be aware that 00110101 is exactly the same as 110101. In reality, computers generally work with a computer word, which is a specific number of bits that can be used for each instruction or piece of data, and all transmissions are the same size as the computer word. The most significant bit is the leftmost bit in a binary number. This is because its column heading has the largest value, and therefore, whether or not there is a 1 in this column has the most significant effect on the total number being represented. The least significant bit is the rightmost bit in a binary number, as its column heading has the lowest value. Therefore, whether there's a 1 in this column has the least significance in the overall value being represented. To convert a number from binary to denary, start by writing out your binary table with all the column headings at the top as they should be, starting from 1 on the right and doubling as you move left. Write your binary number below with the rightmost digit of your binary number in the ones column. All that remains to do is add up the column headings where our binary number has a 1 in the column. So this number, 1101001, contains 164, 132, 18, and 11, for a total of 105. There is also a short algorithm you can follow to convert from denary to binary. First, write out an empty table with the column headings for binary. I'll convert the number 74 to binary to show you how it works. Step 1. Starting on the left, find the first column heading that is not larger than our number. Place a 1 in that column and a 0 in any columns that you have passed. In this case, we place a 1 in the 64's column. Next, subtract the column heading where you placed a number from the number we are converting. We were converting 74. If we take away 64, we have 10 left to use. If the new number is not 0, then return to step 1. If it is 0, then you've already finished. You can fill in with zeros the rest of the number. We go back to step 1 with our new number 10, and starting on the left, the first column heading that is not larger than our number is 8. So we place a 1 in there. We place zeros in the columns that we've passed. We take 8 away from 10. Our new number is 2. We start on the left for the next column heading we haven't looked at, and 2 is the biggest column heading that we can see. We place a 1 in there, We subtract it and we have a value of 0, so we know we can complete our number by filling it out with zeros. That brings us to the end of this video on binary. Join me in the next video when I'll be taking a look at hexadecimal. Use the resources at mrgoff.com to help you revise computer science, and until next time, it's bye for now.